Hi, everyone. I'm Shannon Kuehn, and yes, it's pronounced Keen. I'm a senior program manager at Microsoft. In my role, I spend a lot of time demystifying certain concepts of Azure. Today, I'm here to talk about the next evolution of ARM templates, Bicep templates, right? Or Project Bicep, as you may have heard it called in the broader community. Feel free to connect with me on Twitter and LinkedIn. I tend to try and post a lot of good content. And if you've got questions or you're stuck with a specific concept, drop me a line. My DMs are open. You can always send me a message as well. If I don't know the answer, I probably work with somebody who could give you an answer. So feel free to lean on me if you're trying to make sense of how all of this works together as time unfolds. So let's talk a little bit about Bicep. So at Microsoft, we want customers experiencing Azure for the first time or using Azure as their primary cloud to have the best deployment experience. What we're noticing, or what we noticed, is ARM templates weren't as readily used. And so we wanted folks who were more in the operations side of things to feel a little bit more comfortable embracing infrastructure as code. We believe simplifying the existing language will help many of our customers deploy at scale and have a great experience on Azure. So we'd like to have quicker liftoff versus all of the upskilling that had to happen when everything was in the ARM template realm. So, what is Bicep? Well, it's a domain specific language for deploying Azure resources declaratively. Now, when you hear about infrastructure as code, you'll hear the words imperative and declarative. Imperative is a specific step by step deployment. Declarative sort of defines the end state. The quick example that I can use here is declarative would be you calling your friend to come fix your computer. You don't care how your friend fixes your computer, but it's not working correctly. The imperative way would be you calling your friend and asking how to fix a computer and your friend providing step by step instructions. So the idea here is you want things to be declarative, you want the end state to be there versus following the step by step deployment process. It makes things more straightforward and simpler. So Bicep drastically simplifies the authoring experience with a cleaner syntax, improved type safety, and better support for modularity and code reuse. So what we're seeing is it's less code. You can break apart longer templates, and it seems to be a lot more straightforward in the sense that customers aren't struggling the same way they might struggle leaning on ARM templates, which is basically a JSON file. Bicep is a transparent abstraction over ARM and ARM templates. So this means that anything you do with an ARM template can be done in Bicep. Now, there are some known limitations. Bicep has been something that's been very, I guess, built in ways of leaning on the community for feedback. So if something is not yet available in the world of Bicep that you can do in an ARM template, it should be coming, and there's opportunities to provide feedback. So all resource types, API versions, and properties are valid that are valid in an ARM template are equally valid in Bicep on day one. So I think if you are familiar with infrastructure as code, you might be familiar with Terraform. Terraform isn't always ready to go day one with brand new APIs, brand new resources of Azure. So Bicep will be, as well as ARM templates. We think about the different layers of Azure Resource Manager. You've got a number of different entry points in. So you've definitely got the Azure portal. You've got Azure PowerShell, Azure CLI, and then they get their SDK components as well as REST clients. So everything sort of is able to be manipulated and controlled at that layer. And if you throw templates in the mix, it's happening in the same spot. But Azure Resource Manager, once you plug into the APIs, you're able to build out data stores, web apps, virtual machines, service management, and a number of different resources. You first have to authenticate in, but I think the idea here is it's quite extensible and you're able to do so much with a lot of different tools. And I mean, I'm here to talk about Bicep, but if you're building out environments with PowerShell and you like what you're getting so far, definitely don't stop. But there might be an opportunity to think about ways in which Bicep could help, or even the CLI. So the key terms again are imperative code, it's sequenced, it's step by step. Declarative code, it's the end configuration. I want a web app with a SQL backend, right? I don't care how that gets deployed. I don't care if the environment is spun up in a specific pattern. Item potency or idempotence is the same results each time. So I think as folks move towards this realm of infrastructure as code, you'll have templates that work across a number of different environments. And it doesn't matter how many times you deploy that template, it will not necessarily add additional resources, right? The idea too is if you plug that template into multiple environments, it doesn't change. It builds out the same environment based upon the declarative syntax that you use. So the goals of Bicep are improved validation with better tooling, lower the barrier to entry. I think that one is the biggest with customers I've talked to. The transparent abstraction, so you get to lean on the entire platform, and it's modular. You've got first-class code reuse. The big piece here to talk about is ARM templates aren't going away. So if you are comfortable with ARM templates, and a lot of us have been because we've had to sort of get more comfortable with it over time, you can keep using it, right? If you aren't as comfortable with ARM templates or you want to experiment with Bicep, know that when you build out the environment, it compiles it into an ARM template. So it hits the ARM REST API endpoints and builds it that way. So that's not going away, right? ARM templates aren't just magically gone. Bicep is a simpler way to build out an ARM template. Now, the non-goals are it's one language to rule them all, right? So eventually we feel like Bicep will be the way in which that customers will build things out. And it's a general purpose language to meet any need. So how does it work? Well, you're authoring the template. You build out that template. When you issue out the command to build the template, it transposes it to an ARM template, which then hits the REST API endpoints, the ARM template execution engine of Azure. So it's ever so slightly different. In the ARM template realm, you don't have yourself building out a Bicep template. But the Bicep template is easier to sort of understand and build now, especially if you don't have that development background and you're not familiar with JSON. I believe this PowerPoint is being provided. So the link here is directly to the Bicep documentation. The second link is how you get started with Bicep. So it's building out all of the extra pieces. So there are extensions you want to think about. You want to add the Bicep components to your path on whatever machine you're on. And then the Bicep tutorial. So these are great ways to sort of get started in the realm of Bicep. Let's talk a little bit about the benefits of Bicep next. Take a look at the left side of the screen and the right-hand side of the screen. The left-hand side is a Bicep template, right? You're building out a Cosmos DB, and then you're adding the database account inside of Cosmos. It's literally 33 lines. The same corresponding template is on the right-hand side. Look at the fact that it's not fully done inside this screen, and we're already at over 50 lines of code. Another thing too, you don't have to worry about commas the same way that you do inside of an ARM template. And that used to always trip me up. I didn't realize the commas were important related to declaring different resources in JSON. I have learned how to adjust and pivot and write ARM templates better, but you don't have it the same way in a Bicep template. So Bicep is the first class, it has first class modularity and you're able to reuse code pretty easily. If you think about it like Legos, you're able to stack things together. You don't have to build out some ginormous template. You can pick apart and break things apart, and it allows for it much easier than an ARM template. There's also 0-day support for all Azure resource types and API versions. This is the Azure heat map. So as new services spin up, the Azure heat map will adjust and change, and you're not necessarily trying to go and figure out ways in which to build the environment. If you click on the resources, it'll take you to the right pages to get things up and functional if you want to try out a brand new service of Azure. And I think Azure changes every, I don't know, sometimes it feels like daily, maybe it's more like 6 weeks. There's always something new that comes out. And so you're getting 0-day support for all new Azure components. So the benefits of ARM and Bicep, you get the repeatable results. So ARM templates are idempotent, which means you can redeploy and rapidly deploy the same template and get the same result. That's what I think folks want. You don't want to have configuration drift. You don't want to have a bunch of different environments that were sort of installed manually. The template doesn't duplicate resources as well. So if you're troubleshooting something and you have to redeploy the template, it's not going to build out a brand new VM. It's going to take the existing VM and troubleshoot the components that didn't work right with the initial build. There's orchestration, right? So when a template deployment is submitted to Resource Manager, the resources in the template are deployed in parallel, unless you specify dependencies, like the NIC needs to be built before the VM. This process allows deployments to finish faster. So Resource Manager orchestrates these deployments in the correct order if one resource depends on the other, and you have to specify that in the template. The same concept exists in the realm of Bicep. So you're able to preview. You're able to use a what if tool. It's available in PowerShell and the Azure CLI. It allows you to preview changes to your environment before the template deployment. So this tool details any creations, modifications, or deletions that might be made by your template. So it's really helpful if you're not sure exactly what the template is going to do. I always recommend, too, to have lower level environments that you can do all the experimentation on. Then you've got testing and validation. So you can use tools like the Bicep Linter, which is a Visual Studio Code extension, to check the quality of your templates before deployment. So ARM templates submitted to Resource Manager are validated before the deployment process. So this validation alerts you to any errors in your template before resource provisioning. And it's great because it's a little red squiggly lines. So you want to have less red squiggly lines to be able to deploy the template. Then you've got modularity, right? So you can break apart your templates into smaller components and you can link them together at deployment. That helps because I feel like ARM templates and even the nested templates, right? Those become difficult to author as time unfolds. This modularity makes some of that a little bit easier. So you can sort of work collaboratively on a bigger environment. There's CI/CD integration as well. So your ARM templates can be integrated into multiple CI/CD tools like Azure DevOps or GitHub Actions. Then you can use those tools to version templates through source control and build release pipelines. There's also extensibility. So with deployment scripts, you can run Bash or PowerShell scripts within the ARM templates or the Bicep templates. These scripts perform tasks like data plane operations at deployment time. So you can think about adding IIS to a web server. You can think about domain joining. You can think about adding data disks and making sure that they are formatted. Through the extensibility, you can use a single ARM template to deploy a complete solution. So Bicep is built for toolability. There's rich IntelliSense and validation. And I think it's sometimes even a little bit easier to write Bicep now that I've been writing ARM templates. So if you're familiar with ARM templates, it might seem like you're reinventing the wheel and going and learning something brand new. You can always take existing ARM templates and decompile them into a Bicep template. The actual Bicep components that you install and get on your system, they do a best guess attempt at writing a Bicep file. So that sort of helps things out if you're more familiar with ARM templates too. But the IntelliSense is awesome, and I'll showcase that in my demo today. There's also no state management. So you can query the state directly from Azure. So you don't have to worry as much the same way that you would in other scenarios. So let's pause here for a second and let's get the demo ready to go. So I've got Visual Studio Code open. You can add the Bicep extension already on the machine here, but it's as easy as just installing it, and that's the linter. So that's what provides the IntelliSense. Let's close this out here. Let's add a new file. Now the file name is main.bicep, and know that it's launching the Bicep language service because I have actually installed the extension. So let's take a little bit of time here and start experimenting with the IntelliSense. So everything is declared by way of typing in resource. Now, most resources are strings, so STG is how it is abbreviated. Add a space here. Now, this is every single resource provider that you could potentially deploy. I'm looking for a storage account. So let's type that in, and you see all of the different resource providers. We just want the storage accounts. Now you see the API shows up. It's all supported APIs right now related to the blob storage service of Azure. Let's click the most recent API. When we hit space, we're given two options. So now we need to add different components to this storage account. So let's add the equals. Then we need brackets. So when I hit the space bar, you'll start to see the different pieces that it would be looking for. So let's see. Let's pick the location. I'm going to pick East US. Really matter which region. Storage is in all regions. Pick the kind. And let's go with storage V2. These are all the different kinds you can choose from. Storage V2 is the newer version. And you see that I'm space barring over each time. I can back that up to keep the code clean. Let's give it a name. Call it Bicep Demo. 4 zeros and a 1. Storage has to be unique across all of Azure. In fact, I will go one step farther here and put my initials in there. That way we hopefully will get this to deploy. And let me remove a couple of the zeros. Let's talk about the SKU next, because the next pieces here aren't going to be relevant. I'm trying to showcase how quickly you can stand up something from scratch. So the SKU is looking for something a little different. It needs brackets, right? This is where we have to indicate what type of storage we want. So we have specified the kind. The SKU is either premium, it's standard, or it is, let's pull up the name. So it's premium ZRS. So LRS is locally redundant storage, solo redundant storage, geo redundant storage, right? It's all the different SKUs you could pick. We'll just pick premium. I think that works out really well. Now, once I am authenticated in, I can run this without a lot of problems. I may want to get the output, right? Because the blob URI might be something I want to track without having to log into the portal. So you can also get some output to showcase at the end of the deployment. So this is called by way of typing in blob URI, and it's a string. And then we need to declare the string properties, right? But look, you can get all the different kinds of info. And we're going to look for the primary endpoint. And then we need the actual blob URI. So this is ready to go. And this will build out a storage account. So I am fully authenticated in. In fact, I'm showcasing this pretty at a higher resolution. So let me, or not higher resolution, blown up resolution. So let's type this, AZ group creates. So that's my initials. We'll do SBK-bicep-demo. We need to declare the location. Let's hit enter. Takes a little bit of time, but it's now up and functional. So let's go the route of building out the storage account. I'm using the AZ CLI. A lot of folks like the AZ CLI because it's a little easier if you're familiar with, say, Bash, right? Bash shell scripting. So AZ deployment group create. You got to give it a name. Let's call this SBK Azure Storage. Oops. Need to specify the resource group it needs to go into. We will call it, or it needs to go into the one we just built. So SBK Bicep Demo. Now we need to specify the template file. Now notice how I'm in the folder that I have the main.bicep file. So let's type in template file. And I will tab this over. And because of the IntelliSense, you're able to start understanding that it's looking for that file itself. So we will now be building a storage account. Takes a little bit of let's try this with a different name. Oh, it does not like the storage account name. All right, let's change this. Getting my demo prepped. I always like when a demo wants to give you some hard times. Let's make sure everything's saved. Okay, and it's running. Shouldn't take too long. But it's going to go look at everything we've declared here. It's just going to build out a storage account using the most current API. It's going to place it in East US. And I must have had SBK Bicep Demo 001 already in my subscription. Remember, storage has to be unique. And you get a bunch of JSON as the output here. So here's the output. This is the URI. We asked for that, right? So everything has built itself out pretty quickly, all things considered. So I want to take a second here, and I want to make this an ARM template. So the command is bicep build, and I'm going to look for that file again. And you will see another file showing up here. So I want to do a quick side-by-side comparison. So now this is going to start the ARM template language server because I've got a lot of the ARM extensions on here installed. But look at how many lines of code show up. 30 lines of code. Whereas this is 10 lines of code. So hopefully you can start to see that Bicep's something you should probably be playing around with, even if you've never touched infrastructure as code, even if you've never touched ARM templates. Let's move back to the slides real quick here. So Bicep is heavily leaning on community related to feedback and contributions. So the idea here is to find it on GitHub. Also know that if you are familiar with the ARM template quick start repo, there's now a bunch of Bicep code in there for each one of the templates that have been built over time. So you can go to the GitHub repo, you can go to the quick starts repo, you can get an idea of how this works. And then there's also the ARM template reference in our documentation that now has Bicep examples as well. Another thing to do here would be to follow Bicep Lang on Twitter. There's a lot of great info that gets shared there as well. You can also think about joining the ARM and Project Bicep deployments. It's a customer community. So this is something I always suggest customers continue to, or at least experiment with. Maybe once you feel a little bit more confident, you'll join this customer community. This is a great spot to get info on how the language will change and evolve over time. So that takes us to the end, and I want to thank the folks at Define Tomorrow for asking me to speak. Hopefully you found this session invaluable and informative. Feel free to connect with me on Twitter or LinkedIn, and I hope you've at least realized Bicep isn't as scary as it might seem. So, until next time, happy infrastructure as coding.